While Docker might be the first thing that comes to mind when thinking about containers, Docker is not the first or only way of creating them. Let's briefly take a look at some other container and container adjacent runtimes. Containers, or at least the idea of them, has been around a long time. The first attempt to isolate workloads came with the chroot, or change root syscall, created by Bill Joy in 1979 and popularized by 4.2 BSD in 1982. Chroot, which is short for change root, allows administrators to change the root directory that applications see. This way, an application can think it has access to an entire file system when it really only has access to a single folder. You can still create and use chroots today. Check out this link if you're interested in playing around with that. Chroots were convenient for isolating apps from each other, but they could only really protect a host's file system. Applications in chroots could still see and interact with other applications on a file system if they had the right libraries and applications in their chroot. BSD jails and Solaris zones merged into FreeBSD in 1999 and Solaris in 2004, respectively. These both build on chroots in a big way. With jails or zones, administrators could create entire virtual environments for applications instead of just quote-unquote virtual file systems without needing to emulate hardware like virtual machines can. Like today's containers, administrators could restrict what processes saw or used in a jail or a zone without processes knowing that they were being restricted. Not to be outdone, Linux gained a similar superpower in 2007 with Linux containers, or LXC for short. Thanks to significant contributions from Google, Linux containers use control groups and namespaces to provide much of the same functionality as BSD jails can. See the last section to learn more about control groups and namespaces. LXC is still in active development, and you can use it today. This is the documentation for getting started with Linux containers. If we were to look at this, you would notice that there are a lot of steps involved. You need to create a mapping between your user's ID and a user ID in a container, manually create a network bridge between LXC's network and yours, create a configuration file, and more. These steps might be overwhelming for a developer who just wants to safely run an application in a machine. This is where Docker really shines. Docker has three particular advantages that I like. First, Docker makes configuring container environments really easy. Users can use Docker files to tell Docker how their container should be configured. Docker then uses these Docker files to package your app and its environment into images. You can configure almost anything in a Docker file. It's quite flexible. We'll learn more about Docker files in Chapter 3. Second, Docker makes it really easy to share images. Users can share their application images through the Docker Hub, a global repository of images maintained by Docker. Users can create registries as well as create alternative registries hosted on the internet. Third, the Docker command line interface makes creating and starting containers really easy as well. You don't have to worry about configuring UID mappings, network interfaces, or Docker configuration files. Starting a container is as easy as running docker run. Adding volumes to those containers and joining them with internal networks is similarly straightforward. We'll explore some of this in more detail in Chapter 3.